Okay, so the first one, it gives me tangent of x times cosine of x. So tangent of x times cosine of x. Well, I'm going to try to write everything in terms of sine and cosine. I know tangent is the same thing as sine over cosine. So I can write that as sine of x over cosine of x, and then I'm going to bring down the cosine of x. Now when I multiply fractions, what am I trying to do? I'm going to reduce, if I can, cross-reduce, right? Anything I can cancel. Well, I can cancel the cosine from the numerator and denominator, which leaves me with sine of x over 1, which I can write as just sine of x. And if you have a question, stop me. The beginning here is the whole groundwork. So if we confuse now, I need to re-explain it before we get to the difficult ones. Second one, sine times cosecant. Okay, well, I'm going to try to write everything in terms of sine and cosine. Well, I know cosecant is 1 over sine. So I could write this as sine of x times 1 over sine of x. My sine of x's will cancel, which leaves me with just a 1. So, okay, 3, I've got cotangent divided by cosecant. Okay, so I'm going to do it the long way first, and then I'd show you how I'd actually work this out. Okay, so if I looked at this, let's just do the rules that we have seen so far. Cotangent, I want to write that in terms of sine and cosine. Well, cotangent is cosine over sine. So I could write this as cosine of x over sine of x. And then that's over. And then cosecant of x I can write as 1 over sine of x. All right, that's using straight definitions. Cotangent is cosine over sine, and that's divided by cosecant, which is 1 over sine. So maybe you can look at this and know what you're doing. I get confused when I see fractions inside fractions, so I always turn it into a 5th grade division problem. So that's the numerator divided by the denominator. And then what can I do? I can multiply by the reciprocal. Now the signs cancel, which leaves me with cosine of x over 1, which is just cosine of x. Questions there about functionality, what we did? Now here's how I would work it. The way reciprocal functions work, if you look at it, sine is 1 over cosecant. That means what? If I have cosecant in the denominator, I can move it to the numerator and it becomes sine. Cosecant is 1 over sine, which means if I have sine in the denominator, I can move it to the numerator and it becomes cosecant. So when you swap from the numerator to the denominator, a trig function, you change what it is based off of its reciprocal identities. So if I was working 3, what I would do is I would say cotangent is cosine over sine, but then I would move cosecant to the numerator and make it sine. That's 100% how I would work that. Because when I move cosecant from denominator to the numerator, it becomes sine. See the top reciprocal identity? Does that make sense, what I'm trying to put down? And now what could happen? The sines would cancel, which would leave me with just cosine. Yes? I think it's going good. 4. I see cosine squared. As soon as I see cosine squared, I'm thinking, I'm going to try to use a Pythagorean identity. So because I have cosine squared, well, I would like for that other term to be sine squared. That way I could have sine squared plus cosine squared. I could rewrite it as 1. Well, the first term has a sine, but it's not sine squared. It's sine over cosecant. So I'm going to move cosecant to the numerator, and it becomes a sine. So now I've got sine of x times sine of x. Well, what is sine of x times sine of x? Sine squared of x plus cosine squared of x. Now that's a Pythagorean identity. Sine squared plus cosine squared is 1. To look at 5, I've got sine over cosecant. Well, that looks familiar, right? Looks just like the last problem. So I know if I move the cosecant to the numerator, it's going to become a sine, and I'll have sine squared. All right, so what about the other side? I've got cosine over secant. So I'm going to try to move secant to the numerator because I want everything in terms of sine and cosine. So if I move cosecant to the numerator, that becomes a sine squared. If I move secant to the numerator, that becomes a cosine. So now I've got cosine times cosine, which is cosine squared. Sine squared plus cosine squared is 1. Questions on 5. 6. I've got trig functions to the 4th power. Well, I only like it if it's to the 2nd power or to the 1st power. But what I notice is it's 2 terms, both to the 4th power, that are being subtracted. Any ideas? It's the difference of perfect squares. So I can factor that as cosecant squared of x plus cotangent squared of x times cosecant squared of x minus cotangent squared of x. Now, are these Pythagorean identities? Do I have cosecant squared plus cotangent squared?
Not quite.
No.
Similar.
I can move which one? Okay, so if I move cotangent squared over, it would then become negative. So I could make the identity say cosecant squared minus cotangent squared. So I could make it say this one. Does everybody see what we're talking about? If I take 1 plus cotangent squared equals cosecant squared and subtract cotangent squared from both sides, I think about moving cotangent squared over. So that becomes 1 equals cosecant squared minus cotangent squared. So cosecant squared minus cotangent squared, I can substitute in a 1 there. But now I can't make it say cosecant squared plus cotangent squared. So, like right here is one of the problems where I would say I have a hard time knowing where to stop. Okay, I could stop right here, and I don't know if that's the final answer or not. I've simplified it, but I know I could simplify it again. Because what is cosecant squared? Cosecant squared is just 1 plus cotangent squared. So right here where I had cosecant squared, I could substitute in a 1 plus cotangent squared for cosecant squared. And then I've still got the plus cotangent squared from the original problem. You see what I'm talking about? They're just using substitution. And now what is 1 plus cotangent squared plus cotangent squared? Now I have 2 cotangent squareds. So I think that's the final answer. I think that's simplified. But you can make a case that this is simplified. So again, the biggest complaint is where do you stop? a good question. Okay, we'll look at 7. This is something that's already been factored. 1 minus sine times 1 plus sine. Any ideas? What should we do? I would distribute. Get rid of those parentheses. So 1 times 1 is 1. 1 times sine of x is sine of x. Negative sine of x times 1 is negative sine of x. So that means these two parentheses are conjugates. Where I just change the sign between them, which means the middle two terms cancel. And then at the end, I've got negative sine times sine. That's negative sine squared of x. So now do I have a trig identity that says 1 minus sine squared? Not in its normal form, don't flip, but I could take the top one and move sine squared over. And then I would have cosine squared equals 1 minus sine squared. So I can rewrite this as cosine squared. Yeah, so as soon as I see fractions, I don't really like dealing with fractions. So because I have 1s in the numerator, I'm going to move the trig functions from the denominator to the numerator. So I know one of our rules was we try to write things in terms of sine and cosine, but that's just a general rule. That's what makes these so hard. There's no one way to tell you how to do it. You just have to follow steps, follow your gut instincts. When I see 2 trig functions that are squared, I'm automatically thinking, can I use a Pythagorean identity? So I'm going to move these trig functions to the numerator. So when I move sine to the numerator, it becomes cosecant. When I move tangent to the numerator, it becomes cotangent. And then keep the sign between them, which was subtraction. So now do I have a trig function that says cosecant squared minus cotangent squared? Well, the middle one, I can make it say cosecant squared minus cotangent squared by moving the cotangent squared over. And so cosecant squared minus cotangent squared would be 1. Is everybody okay with that? I know I'm not writing that down. It's the same thing I just wrote down earlier. We're manipulating the Pythagorean identity to make it say what we want it to say. We're going to look at 9. I've got cosine times tangent plus 1 times sine minus 1. This looks like something I could distribute, but I'm just thinking in my head, what's going to happen when I multiply cosine tangent times sine? That's going to give me a term that says cosine tangent sine. That's not pretty. So can I rewrite one of those trig functions to be in terms of sine and cosine? I can. I'm going to rewrite tangent to be sine over cosine. Now what's happened when I've done that? Now I've got a cosine in the numerator and in the denominator, which leaves me with sine of x plus 1 times sine of x minus 1. And I've had a problem very similar to this already, right? It was a little different, but it's very similar. So if I distribute, again, these are conjugates, which means my middle two terms are going to cancel. That's going to leave me with sine squared of x minus 1. All right, so this is going to be a little bit trickier. Can I make one of my trig identities say sine squared minus 1? Yes, I would have to move on the top one. I'd have to move the 1 over to give me sine squared of x minus 1. That means I need to move cosine squared over to the other side, and it's going to become negative. So my answer is going to be negative cosine squared of x. Ready to write that down, or can y'all do that in your head? So on 10, they've kind of been nice to us. Look at the numerator. The numerator is what? Exactly what I just got done doing. It's the exact same thing. So I know what the numerator is going to simplify to be. The numerator is going to be negative cosine squared. The denominator is cosine squared. So now what's negative cosine squared divided by cosine squared? Negative 1. Remember that negative has to stay.
So if you just had a problem like that, you would just simplify the numerator and divide.
Yes, so if I had one like 10 before I'd done 9, I would do exactly that. I would simplify the numerator, especially because I see that tangent in there. I'm going to write that as sine and cosine. And then I'm going to leave the cosine squared alone until I make the numerator look a little prettier. So it's kind of like, who did that in here? We picked an ugly side and made it try to look like the pretty side. What was that? What were we doing with that?
We were dealing radicals, I think, at the time.
George from radicals. I can't remember what the math was, though. So here's the deal. If you ever see a negative value in the argument, before you do anything, you've got to get rid of it. That's always the first thing we've got to do. I can't have a negative in the argument when I'm simplifying these trig identities. So I'm going to use my even odd identities to get rid of those negatives. So for sine, what does it tell me? If I have a negative in the argument, it comes out front as a negative. So sine of negative x is the same thing as negative sine of x. And then cotangent of negative x. That tells me what? If I have a negative in the argument, it comes out front as being multiplied. And so now I have a negative times a negative, which I know is going to be positive. And I've gotten rid of those ugly negatives inside the arguments. Okay, now can I simplify again? Well, I don't really like cotangent, so I'm going to rewrite cotangent as cosine over sine. And then this is multiplied by sine of x. So notice I've went ahead and dropped those negatives, right? Because a negative times a negative is a positive. If you left them, that would be fine too. And then what happens? My sines cancel, and I'm left with cosine. All right, what's the deal on 12? I have a negative in the argument of sine. A negative in the argument of sine comes out front as a negative. So this becomes sine of y minus sine of y. Well, that's 0. If I have something and I subtract it away, then I have nothing. Now this looks like a disaster. First thing I see is negatives in the arguments. I'm fixing that first. Before I do anything else, get rid of the negatives in the argument. So look at cosine. What happens when I have a negative in the argument of cosine? I just drop it, right? Because it's even. So I can drop the negative for cosine. So cosine of negative x is just cosine of x. Okay, what is sine of negative x? That would be negative sine x. And there's a minus sign. What's cosine of negative x? I can just drop the negative. It becomes cosine of x. And then this sine of x, it was already looking pretty. So this is kind of ugly. Yeah. I could combine it the way it is. But I know cosine over sine is the same thing as cotangent. So I'm going to write this as negative cotangent of x minus cotangent of x, which means I have negative 2 cotangents of x. I combine my like terms. And I think this looks a lot prettier than having that ugly fraction. So again, anytime I can rewrite it as one term, That's what I want to do. Right? What did some people, I'm sure, think about trying to do? Move sine to the numerator. Right? Because we don't like fractions. Well, let's just think through what would have happened. If I move sine to the numerator, it becomes cosecant. So it's cosine times cosecant. Is that going to help me anywhere?
No.
No, it's just going to muddy it up some. So as you work these problems, like especially when we get to the harder ones, I won't even know what's the right move before I'm making it. I just try something. And if it looks worse, well, undo it. Try something else, okay? You can't break these as long as you follow these rules. But again, this is one of those, if you sit there and stare at it and do nothing, you're not going to find it right that way either. You got to do something. (14). I have a negative in the argument of the second sine. So before I do anything, I'm going to fix that. With sine, the negative in the argument comes out front. So I have 1 plus sine of x times 1 minus sine of x. Now these two parentheses are conjugates. This looks familiar. 1 times 1 is 1. Sine of x times negative sine of x is negative sine squared of x. Can I make one of my trig functions say 1 minus sine squared? The top one. 1 minus sine squared is cosine squared. All right, 15. I've got 1 minus 1 over cosine squared. So I'm going to move cosine squared to the numerator. And that becomes secant squared. Do I have a trig function that says 1 minus secant squared? I can make the bottom one say it. If I move secant squared over, I have 1 minus secant squared, which means I need to move tangent squared over. And it's going to become negative tangent squared x. So 16, I could see myself messing up 16. There's a lot of ways to do it. Because both of these are Pythagorean identities. And they kind of go together. Like, if I move secant squared up, it's going to become cosine squared. And when I look, none of my trig functions have tangent squared and cosine squared. Right? Tangent squared's on the bottom one, cosine squared's on the top one. So I know that's probably not a good thing to do. But the way they're written now with tangent squared and secant squared, that's the bottom one, deals with both of those. So what I would do is I would take the side that has two terms, which would be the numerator, and try to use my Pythagorean identity to write it as one term. That would be my first thought. So I have negative tangent squared minus 1. Can I make that bottom one say negative tangent squared minus 1? I can if I move them both over. It becomes a negative tangent squared and a negative 1, which means I'm going to move the secant squared over. It's going to become a negative secant squared. So I could rewrite this as negative secant squared of x over secant squared of x. And now that's pretty. I can simplify that, no problem. Secant squared over secant squared is 1. And I'm left with that negative, which means I have negative 1 out front. So 17. Tell me what you see on 17. I see a cubed. That's new. And I also see a negative in the argument. So first thing I'm going to do, fix the negative in the argument. Cotangent of negative x, I can rewrite as negative cotangent of x.
Excuse me, teacher. I've been asked to announce that at the ball game Monday, the theme will be neon, and you need to wear your neon and glow sticks. So glow big or go home. Everybody be there with your neon and your glow sticks. Thanks.
Hey, it's low big. Low big. Low big.
Okay, so in the numerator,
Yeah.
what do we think?
Pythagorean identity.
Well, the Pythagorean identity has to have squared
Oh, you can't.
trig
You
functions.
can't take the square out of the cube.
Can you combine the other tangent with the other tangent?
Kinda. Both those terms have a tangent. So I could factor it. Hey, remember the first week of the year when we did a factoring worksheet and I told you it's never going to go anywhere? I can factor because there's a GCF. Both those terms have a tangent. So let's factor the tangent out. Now that tangent cubed will become a tangent squared. And then the second term, I'll have a secant squared. Well, that looks kind of like a Pythagorean identity. Can I make it say tangent squared minus secant squared? I can. The bottom one. If I move the secant squared over. So then what would I get? Tangent squared minus secant squared would be -1. So I could rewrite this as tangent of x times -1 over negative cotangent of x. Well, okay, what if I move negative cotangent to the numerator? It would become tangent. So I would have, what do I have in the numerator now? I have a negative tangent, and I'm moving a negative tangent up there. Can y'all see that? So that would be negative tangent times negative tangent, which would be a positive tangent squared of x. That's kind of a lot of moves to do in our head. But I believe in you guys. I think you can see it. Okay, when I look at 18. So my first thing I'd want to do, I'd want to move sine to the numerator. That'd be the first thing I'd want to try to do. What happens if I move sine to the numerator? It would become cosecant. Is cosine squared cosecant going to do anything for me? No. So that's a bad path forward. So let's quit that idea. That's bad. What else am I thinking? I'm thinking, well, the second term's a fraction. And when I add fractions, I have to have a common denominator. And so the first term has a denominator of 1. And if I needed to make it a common denominator, I'd have to multiply the first term by sine of x. And I do that on top and bottom. And so now I'd have sine of x times sine of x, which is sine squared of x over sine of x, plus cosine squared of x over sine of x. And the whole point of getting a common denominator was to be able to write it as a single numerator. So I've got sine squared plus cosine squared all over sine of x. Hey, that looks nice. What's sine squared plus cosine squared? 1. I can move sine of x to the numerator and it would become cosecant of x. Well, okay.
Quite the on.
Okay, so I see a negative in the argument. I need to fix that. It's always first. So with negative cosine, what does that mean? A negative in the argument of cosine, I drop it. Just as still cosine. So this is going to be 1 over 1 plus cosine of x plus 1 over 1 minus cosine of x. And now I'm adding fractions again. So one thing people sometimes try to do is move cosine to the numerator. Okay, you can't do that. You have to move the entire denominator to the numerator because it has the plus sign between it. So I'd have to move 1 plus cosine to the numerator, and that's going to be a headache. So let's don't even go that route. So let's go a different route. Let's think like we did in the last problem. I'm adding fractions that have a not common denominator. So in order to add them, combine them, I need to get a common denominator, which means I'm going to multiply this fraction by 1 minus cosine. And I'm going to multiply the first or the second fraction by 1 plus cosine. And now, we can worry about the denominator later, but I know my denominator is going to be 1 minus cosine of x times 1 plus cosine of x. And I can probably distribute that out and make that look pretty in just a second. I'm going to focus on the numerator. So 1 minus cosine times 1 is 1 minus cosine of x plus 1 plus cosine times 1 is going to be 1 plus cosine of x. Now let's combine like terms in the numerator. 1 and 1 is 2. Am I going too fast? Sorry, I realized I was getting carried away right there. 1 and 1 is 2. Negative cosine plus cosine cancels. Now in the denominator, if I distribute, because they're conjugates, I'm going to get 1 times 1 is 1. And then the last term, negative cosine times cosine is negative cosine squared of x. That looks like a Pythagorean identity. Can I make this say 1 minus cosine squared? I can. It's going to be sine squared. So I can write this as 2 over sine squared of x. But that looks kind of ugly as a fraction. So I'm going to move sine squared to the numerator. And that's going to give me 2 times cosecant squared of x. Yeah, that looks good. Okay, so these problems look similar to the problems we had at the end of the last chapter, or our last set of problems. Remember how we had arc sines, and inside that, then we had a cosine? The difference is, the problems we had been working, they would say something like cosine of arc sine of, and then it would give a ratio, like radical 3 over 2, or negative a half in the argument. Well, here my argument is a variable, so that's going to make it a little bit different, but it's still the same process that we were doing before. So, if I had to work this problem, I start on the inside. This says the arc sine of x. Arc sine is defined for the first and the fourth quadrants. Because it's positive, I'm in the first quadrant. Sine is a ratio of the opposite over the hypotenuse. So, what's my opposite side here? Well, look at the ratio. The ratio is just x. Can I write that as x over 1? Yes, I can. So what's my opposite side? It's x. What is my hypotenuse? It's 1. Now, when we worked these problems before, we always had a 30, 60, 90 or a 45, 45, 90. We had a triangle that we recognized. Here, I don't have a triangle that I recognize. But what I do have is a right triangle where I know 2 of the 3 missing sides. How can I find the third side of a right triangle? Pythagorean theorem. So I could say a squared plus my missing side, let's call it b squared, equals the hypotenuse squared. Right? A squared plus b squared equals c squared. Now we want to solve for our missing side. So we're going to solve for b. So if I do that, that becomes b squared equals 1 squared is 1. I move the x squared over and it becomes negative. Is everybody okay with that? Now we take a square root of both sides. That tells me b is equal to the square root of 1 minus x squared. So now I know my missing side. My missing side here would be the square root of 1 minus x squared. Do I know what this angle is? I don't, but it's still my central angle, theta. So I have drawn the triangle that I need for arc sine of x. I don't know what the angle is, but right here's that angle. We could call it theta. So then what's the next question? The next question would be find cosine of that angle theta. Well, the triangle's already drawn for us. There's no point in drawing it again. So what is cosine of theta? Cosine is the adjacent over the hypotenuse. So that would be the square root of 1 minus x squared over 1, which is just the square root of 1 minus x squared. Okay, let's do one more here. I'm asked to find cosine of arctangent of x. So again, I'm starting with arctangent. That means that's a ratio of sides. So I can write this as x over 1. And I know tangent is the opposite over adjacent. And because it's positive, I'm in the first quadrant. So I draw my triangle. That means my opposite side is x. The adjacent side is 1. This time I'm missing the hypotenuse, c. But I know 2 of 3 sides of a right triangle. So I can use the Pythagorean theorem to find the missing side. That would be a squared plus b squared equals the hypotenuse squared. Now I'm trying to solve for c. So I'm going to take a square root of both sides. That's going to be the square root. 1 squared is just 1 plus x squared is still x squared is equal to the hypotenuse c. So now I know my third side is going to be the square root of 1 plus x squared. And so I don't know what this angle is, but I know it's this angle here. It's the angle theta. I'm not sure what it is, but it's some angle theta. So now I'm finding cosine of that same angle theta. So I go here to the angle. Cosine is the adjacent over the hypotenuse. So that's going to give me 1 over radical 1 plus x squared. Now because it's 113, I don't like a square root in the denominator. So what do I need to do? Rationalize the denominator by multiplying by the square root of 1 plus x squared in the numerator and the denominator. 1 times the square root of 1 plus x squared is the square root of 1 plus x squared. And then on the bottom, radical times a radical, same thing underneath it, means those radicals cancel. So this could be radical 1 plus x squared all over 1 plus x squared. Kind of like how when we get 1 over radical 3, right, we have to rationalize to get radical 3 over 3. Okay, so again, this is a throwback to kind of what we were doing in Algebra 3 in the first half of pre-cal, where we were asked if a function was even, odd, or neither. So if you remember, even means the graph was symmetrical with respect to the y-axis. That means I could fold it over the y-axis and I would get the same thing on either side. Odd means it's symmetrical with the origin. Think about an x cubed function that goes through the origin. That's symmetrical with the origin. And then neither means it didn't have either one of those symmetries. So when we graphed it, we could tell if it had symmetry or not by looking at it. Well, these aren't graphed. So we learned another way to tell if a function was even or odd. And here it was. So let's just do a quick refresher. If we plugged in a negative value and we got back what we started with, that meant that the function was even. So again, I'm writing that in symbols. Here's what that symbol means. I plug in the negative x, and once I plug in the negative x, I get back what I started with. I just get regular f of x. That means I have an even function. Now the other side of that was if I plug in a negative value and what I get back out is negative what the function used to be. So that means every sign changed. You guys remember that? If I changed every sign of my function, that meant it was odd. And if neither one of those things happened, then it was neither. That means if some signs change, but some remain the same, that makes it neither. Okay, so when I look here at 26, I've got 1 plus cosecant of beta. So in order to tell if this is even or odd, we want to plug in a negative variable. So we're going to plug in negative beta. So that makes this 1 plus cosecant of negative beta. And now what do I have? A negative in the argument. So I'm going to use my even-odd identities. So what happens when cosecant is negative? We pull the negative out front, right? Because it's the reciprocal of sine. So this would give me 1 minus cosecant of beta. And that's simplified. So does it look exactly like it did when it started? No. Did it change every sign? No. So this is neither even nor odd. It's neither one. You guys remember doing problems like that? We were doing them with polynomials before, where we had like an x to the third and x to the second with all the coefficients. But now we're going to do it with trig functions. It's the same idea. Can we look at 27? 27, I've got f of x equals sine over x. So again, to determine if this is even or odd, I'm going to plug in a negative variable, negative x. That's going to give me sine of negative x divided by negative x. Now use your even-odd identities. A negative in the argument of sine comes out front as a negative. So this can be rewritten as negative sine x over negative x. Well, now I have a negative divided by a negative. Negative divided by negative is positive. So that leaves me with sine x over x. That's simplified. Does it look exactly like it did when I started? Yes. It's even. Questions? And then the last one here. Same idea. Plug in a negative argument. If I plug in negative x, that's going to give me negative x times cosine of negative x. What I need to fix? A negative in the argument. A negative in the argument of cosine gets dropped. I don't have the negative anymore. So that means I write it exactly the same way, except just drop the negative. So now I've got negative x times cosine of x. I don't even have to put that in parentheses anymore. Can't be simplified. So did I get exactly what I started with? No. Did I change the sign of everything? Yes. It's just one term. Right? There's no plus or minus between them. It's already one term. It used to be a positive term. Now it's a negative term. That means that this is odd.